Okay, good morning. So if you remember, we started talking about how we can use integrals to calculate volumes, but I told you that they are called volumes of revolution. It means that you have an area, you rotate it about the x-axis, it will generate you a solid object, and then you are able to calculate the volume of that solid object. Yes? So for example, if I want to calculate the volume of a cone or of a sphere, I cannot directly attack to the problem. I need to think about a curve in 2 dimensions so that when it is rotated about the x-axis, it will generate that particular solid object that I am interested in to calculate its volume. Yes? Now and then we learned that, so that was what was the formula, if you remember? Let me just remind you a little bit. By the way, I solved some problems for the second group, and I uploaded the video, yes? So if you are interested to see some of those problems, you can also check that video. So here we have y equals to f of x, and then assume that I consider the area below the curve here and restrict it with the vertical lines A and B. And then I take and rotate this about the x-axis. It will generate, so for example, something like that. Something like this, yes? So it will generate the solid object. If I want to calculate the volume of that solid object, V, the formula which I was trying to motivate you, hopefully you understand what's going on, is integral from a to b, not your function squared dx. So that was the volume formula for the volume, and I motivated you exactly by slicing it to thin cylinders and finding the volume of each cylinder and adding those volumes together. And we solved some problems, yes? And I remember we had one problem that I haven't solved, so I will solve that one. But before doing that, let me start with a simpler one, which is in the book. So, and I told you that after that, when I solve some problems for you, also plan this problem. So here we have 2 curves, f of x, and the other one, for example, is g of x. And then now we rotate this area between 2 functions, this area. Only this area about the x-axis, yes? And it will also generate a solid object but hollow inside, yes? So then we learn that the volume of this will be like this. Pi integral from a to b. It was f of x squared, the function above squared minus the function below squared, and then dx. What was the motivation? What was the reason that this formula is correct? Because momentarily we can ignore this function. We can consider this bigger area and rotate it. It generates a solid object. Its volume is just this one. And then I calculate the volume generated by this one, which is similar but g of x instead of f of x, and then I have to subtract them to find the volume that I am interested in. And this is why you see the subtraction here. For this one, I stated an example for sine and cosine, if you remember, what I didn't find time to solve it. Before solving that problem, which is a little bit harder, let me just choose one example from the book, and then I will solve that one for you. So that's a good example in the book. So this is the problem here. We have 2 curves. One of them is y equals to x squared, but of course y equals to x squared also goes in that region, but I don't need that. And then I have another function which is the square root of x. If you draw that, this becomes something like this, and that is only one branch, so it doesn't go here because square root of x is always positive, so it cannot go below the y-axis. Sorry, below the x-axis. And now I am interested to take this area between these 2 curves and rotate it about the x-axis. I don't know, can you imagine what will it be? So it's something, it's still hollow inside, yes? So what if you want to imagine, you can imagine it like this. Yes. So I don't know how to draw it, but this part is the one that you are interested. This part will be carved out, yes? So that shape, I don't know what we can call it, but whatever it is, we want to find its volume. Is that clear? Okay, so how should I do that? So you really don't need that much imagination for solving these problems. You just need to understand how is it going. Because this area is between two functions, it is clear that I have to use this formula. And then just I write this formula and then we are done. So the point is that I have to write pi integral. So what are the lower and upper limits in this case? So this area is restricted between the y-axis and this line, which is still missing for us. So I should go from here to here. From here it is clearly 0. But what is here? That point is the intersection point of these two. So that's the x-coordinate of this intersection point. So it motivates me to find the intersection point and read its x-coordinate. That is what I want. Yes? So what I have to do, I have to solve a system of equations. So this means that x squared is equal to square root of x. Then to get rid of a square root sign, I square it. It becomes x to the 4 is x. I move it to the left, equals to 0. I factor x out. Then it becomes clear. Either x is equal to 0, which was predictable for us from the beginning, or x to the 3 is 1, which means x is 1. So these are two x coordinates. So it was already clear for us that one intersection point is here, and that other point is 1. So we now know that this number is 1. If it is a problem in the national exam and then this number is not given, that is part of the solution. So you have to write the intersection 1 and then find the answer. And then I have the function above here, the greater function. In this region, square root of x is higher than x squared. So I have to write that one. What is squared? Yes? Minus the second function squared, and then calculate the difference and then integrate. If I can calculate this integral, that integral is the volume generated by that revolution. Okay, but these are usually simple. So here mainly the problems for you is how to set up the integral. But the integrals are not that hard. Of course, sometimes they become hard. When I see the exercises, the integrals involved in the exercises for the volumes are not that hard. So this becomes pi, and then I get integral from 0 to 1. Square root of x squared is x minus x to the 4. And then this is a very even math 3 students can solve that, yes? So a primitive function for x. So let me just write pi. A primitive function for x is 1/2 x squared. A primitive function for the other one is 1/5 x5. And then I have to run this from 0 to 1. And the good point is that for 0, I don't have any problems, because if I replace x with 0, this will vanish. And the only thing is that I have to put 1. So this is why I do not make it 2 branches. I just write it 5. I put 1 here, it becomes 1/2 minus 1 over 5. And then if you simplify it, it becomes 3 pi over 10 volume units. That's the exact value, and you have to keep it exact. Any questions? Okay, so now let me solve the problem that I told you to do it. That's also simple, but the integral becomes a little bit more involved. What I'm going to do, the problem was this. I have the sine function. Yes, this is the sine function here, of course, is 2 pi, here is pi, and here is 0. Yes? And then I have cosine function. Cosine function starts from the same height, but it goes to 0 at pi over 2, and it goes to -1 at pi. So if I draw that, yes, of course, I remember I continued, but I don't need to do that. I just want to take this part, which is restricted between cosine function and sine function and the y axis, and I want to rotate this about the x-axis. That's the same problem, but the curves are different. Yes. And I want to find the volume of revolution if I start rotating this about the x-axis. Again, it would be something carved out, yes, hollow inside. Okay. So what I have to do, I have to write the formula pi integral. So what are the limits? Again, the limits, the starting point is 0, is clear, but I have to go up to this point. This point is also clear, where sine and cosine become the same, yes? Because if I want to find that, I have to solve the system. So this means that sine x is equal to cosine x. For example, you can divide by cosine, it becomes tangent of x becomes equal to 1. But in the region between 0 and pi over 2, because cosine becomes 0 at pi over 2, tangent of x becomes 1. It means the only answer that I needed here is pi over 4. Of course, there are infinitely many solutions, but the only one is between 0 and pi over 2 is pi over 4. So then it means that I have to go up to pi over 4. The function above is cosine, so it becomes cosine, not cosine. You see the formula tells you take the function, square it. So this becomes cosine squared, and then minus sine squared dx. Yes, I have to calculate this integral. So any ideas how to do it? That was very trivial there. Here is also very simple, but I want to see how do you solve it. You need to find a primitive function for this, or you can simplify this and then do the primitive function. Yes?
Simplify to cosine 2x?
Yeah, that is the famous cosine 2x formula. Yes, thank you. So this is nothing. If you see that, this is why I'm saying that memory is important, because if this is totally unfamiliar to your eyes, then you will probably not be able to solve it at all. But at least if this is familiar, then you will go and look for it in the formula sheet. So that is cosine 2x. And then this is very, very simple now, because we already have the formula for cosine kx in the table. What was the primitive function of cosine kx? Do you remember? F. Here, if I have cosine kx, the primitive function becomes 1 over k sine kx. This we also have it in the formula sheet. So if I continue here, this becomes pi. This becomes 1 over k, which is 1 over 2, but sine 2x. And it goes from 0 to pi over 4. Okay, so what happens now? I have to put pi over 4. I have to put 0. But 0, I don't need to be worried, because sine of 0 is 0. So the only thing that I have to care is the number above. So this becomes pi over 2 sine 2 times pi over 4. But 2 times pi over 4 is pi over 2, and sine pi over 2 is 1. So this becomes just pi over 2, volume units. Yes? Okay, I can see that there are some other, so they have expanded this a lot in this book. So let us try to ask you one question here. Now, let me give you this function, y equals to, let me keep it simple to understand what I mean. So x squared plus 2. So what is the graph of this function? It is just the normal squared function x squared, but shifted 2 units up. Yes? So it means that instead of starting from 0, I start from 2. And I draw that. Okay? And this point is 2. Now consider it between minus 1 and 1. If I take this area, yes, and I rotate it about the x-axis and I ask you to find the volume of the revolution, that is very simple. Yes, you already know what to do. If I want to do that, so let me call it volume number 1. If I rotate the whole area about the x-axis, the formula tells me that if I want to calculate, I have to calculate from minus 1 to 1 and take my function and square it and then dx. And then this is a simple problem, so you can continue. How? By expanding it and solve it. Now I see that there are some questions in the book. For example, they ask you not to rotate it about the x-axis, but another horizontal line. So what they mean, for example, let us take this, y equals to minus 1. Yes? Yeah, so this is the horizontal line, y equals to minus 1. Okay. And then you want to rotate about this axis rather than the x-axis. So for example, what I mean is that you need to consider this area now. And rotate it about the y equals to minus 1 axis. And then we want to find the volume of revolution, but not about the x-axis, about this blue line. Of course, here you might say that, okay, I calculate the previous volume, and then I also calculate this volume after being rotated, because that is simple. What do you think it will generate if I just rotate this part? A cylinder. And volume of the cylinder, you have it in the formula sheet. So you can add the volume of that cylinder. Can you tell me what would be the radius of that cylinder? This length will play the role of that radius. And what would be the height? This would be 2 units. So by having the radius and the height, you can in principle read it from the formula sheet and find the volume and then add it there. But if you want to do it a little bit differently, you can say that, okay, every time that I want to calculate the volume, so let us just think in that way. That's a good thing to learn. So I take x here, for example, from here to here, x, and then let me take this one, let me make it a little bit thicker. So now what happens if only I concentrate here? So I am considering the thickness of this very narrow line, which is, I call it dx. So do you remember I have to chop this interval into very narrow pieces and then find the volume of each part and then add them up. Yes? So in this way, so in principle you have very, very narrow rectangle and then you want to rotate it about the x-axis. It will give you a washer, a very thin, not washer should be hollow inside. It gives you a disc. Yes, but disc is also a cylinder, which is a very thin cylinder. Okay, but instead of thinking in that way, I would recommend you to think in this way. You have a very thick line, but very narrow cylinder. The thickness, you call it dx, the change in x, instead of delta x, which is this width. If I make it a small, I call it dx. And then imagine if it rotates about y equals to minus 1, can you imagine it will generate a very thin disk? Yes? Okay, now can you tell me what is the volume of that thin disk? The volume of that thin disk, I call it dV. Yes? This is very interesting way of understanding the integral. Yes? So I go x units to the right, and I draw this vertical line by thickness dx, and I rotate it about this axis. You can imagine that this will generate a very thin disk. Can you tell me what is the volume of that thin disk? Can you tell me what will play the role of the height, if you can call it height, of that thin disk?
dx.
Dx. So, and then you remember the formula for the cylinder, or it is pi r squared h. This is the volume of a cylinder, a disk. So this h will be dx. Yes? And this pi is pi. What I want you to know is what is r? What will play the role of the radius of that thin disk? What? No, there is not. It's not a particular number. But I hope that you can see this length will be the radius. Is that understandable? If I rotate this line, this line about the x-axis, so this line will still be the length of the radius. Is that right? But now I cannot say what is this length, because if I start changing x, this green line will change. So its height depends on x. You cannot say 3/2 or 5 or whatever. That is some number which depends on x. Yes? But if I ask you what is from here to here, how do you calculate it? Okay, forget about this part. What is from here to here? This is x. So what is this height if I want to calculate the height if I give you x? For example, if I give you x is 1/2 and I ask you to find this height, how do you do that? You put it in the function, you find a y. This time, instead of giving you this is 1/2, I have told you this is x. Assume that this is x, and then I want you to find this height. You put x in the formula, you get x squared plus 2. But x squared plus 2 is this height. But you need to find the whole height. So what is the whole height? Can you tell me?
x plus 3.
X squared plus 2 plus 1 unit. Or you can write x squared plus 3. Yes? So that is what you need to integrate. You see, pi x squared plus 3 dx. That is your formula. So this is, if I ask you what I have written on the board, you will tell me this is the volume of that slice after being rotated. And if I have these slices next to each other and I add them up, this becomes the total volume. Yes? But x is not a discrete index. If x is a discrete index, for example, I can say I goes from 1 to n. But x varies continuously. When something varies continuously and you want to add them up, this means that you need to change sigma with integral. Yes? So that is the meaning. So v that I am interested in is the integral of these elements, of these thin volumes, small volumes, from the on the area of interest. So from here to here, x runs from -1 up to 1. And that is the formula that you have to do. Yes? So that is actually extremely important to understand. Yes, this method is superior. They haven't talked about this, but I think this is the best way to understand integrals. Okay? So whenever you want to calculate something, a quantity, that you can slice it and then add them up, you need to remind yourself about the notion of an integral. And what you do, you try to find a geometry there so that you can answer the question for a very thin part or very small part, and then use integral to add them up. Yes? Is that clear? So that's the method that we use. So if I want to rotate this area about the y equals to -1 axis, then that would be the formula. If I wanted to rotate it about the x-axis, the formula was just x2 plus 2 squared. By the way, sorry, you didn't corrected me. I made a mistake here. That's very good that I detected myself. Because that number that I wrote here is r. But it should be r squared, sorry. I ask you what is the radius. This number that I wrote first is just the radius, but in the formula I have radius squared, so that is where this 2 is coming. Yes? And you can calculate this integral. How? In this way, there is only one way for you to calculate is to expand. Yes? So I bring pi out, and then I will have from -1 to 1, and then it becomes x to the 4 plus 6x to the 2 plus 9 dx. And I think it is so trivial, so let us not spend time on it. You can just find the primitive function for these, or are elementary, and then calculate and then find the model. Is that clear? Okay. They have also talked about rotation about the y-axis. Can you tell me what will happen if I rotate this time instead of x-axis I rotate about y-axis? Because x and y-axis are our conventions, yes? We just draw a coordinate system. We usually call the horizontal one the x-axis, the vertical one the y-axis. But geometry doesn't care about, so if you have a sphere, you have a sphere independent of where the coordinate system is sitting, yes? So in principle, we can ask the same question. If instead of rotating an area about the x-axis, I can rotate the area about the y-axis, that also generates a solid object. And that is a sensible question to ask what the volume is. Yes? So I want you to understand what is going on, and then you can predict probably the formula. Yes? So let me just write the formula here. If I want to rotate about the x-axis, as we did so far, what was the formula? The formula, so the function is y equals to f of x, and the formula reads like this: pi integral from, for example, a to b, and then f of x squared dx. But then, what is f of x? F of x is nothing except y. I intentionally want to write it in that way because then it would be easier to guess what will happen if I rotate about the y-axis. Instead of f of x, I write y, it becomes y squared dx. So this would be the formula of the volume if I rotate about the x-axis. Can you guess what will happen if I want to rotate about the y-axis? So I hope that you agree there will be a pi integral from where to where. So let me draw a picture for you here. Okay, so what we can do is this. Let us consider a simple case. Okay, so for example, here, let me consider this point A, this point B, and assume that this is your function. Okay? In the previous formula, we learned what will happen for the volume. What is the magnitude of the volume if I rotate this about the x-axis? Now, I want to rotate an area about the y-axis. So what does it mean? Not this area, by the way. You will not study. This is in the book, but it is only for further studies. Okay, I am not rotating this area about the x-axis, about the y-axis. What I am doing, I am considering this area again. Yes, and I want to rotate this area about the y-axis. Be careful. I can also ask what will happen if I take the same area as before and rotate it about the y-axis. This is a different problem, and this is excluded from the, this is not in the Math 4 course, but it is in the book. If you are interested, you can study, and if you have questions, we can talk. Might be we can solve some of them in Math 5 or something. Yes, let us see how it goes. But then, I want you to, so this one, this volume that I wrote here is this one. Can you tell me what will happen, what do you expect to see if I rotate the green area about the y-axis? It also becomes a solid object. It is completely sensible to ask about the volume. But can you guess? I intentionally wrote this formula in this form so that you can understand what to do. It's not complicated. Yes? Just
Does the integral go from f of a to f of b?
yes. So it means yes, exactly. So let me write this one, c, and that is exactly f of a. And then this one is f of b, which is d. So let me write, the integral goes from c to d. Yes? But what will happen inside the integral? Here, it was y squared dx. It means your variable is x. When I want to rotate about the y-axis, what is varying here is y. So y is varying. So it means that instead of having dx, I will have dy. But could you guess, can you guess what I should write here? By analogy, you see, I am interchanging the role of x and y. So x goes to y goes to x. So it becomes x squared. Yes, that's it. But this is a little bit strange, because so far, whenever you talk about functions, you always express y on the left-hand side, x on the right-hand side. So that I will respect the same thing. For example, I can tell you that this is y equals to x squared. All the way that we have learned about functions, we learn to put y on the left and x, some expression on x on the right. But if I want, I can interchange the role, yes? I can talk about what? X as a function of y. So this becomes x plus or minus the square root of y. So this expresses x in terms of y. But of course, we have to be careful. For example, in this region, x is not negative. So it means that I do not take this into account. So this means that this is the same expression, but this expresses y in terms of x. This expresses the same equation, but x in terms of y. That's it. I'm just interchanging the role of x and y. Is that understandable? There is nothing specific about x and y. That is our human convention. From start, we call the horizontal one x, the vertical one y, yes? And we learn that, okay, we always write y as a function of x, but it is possible to reverse this order. So that is, I just want you to know about it. Actually, that was exactly true for the area. So let us practice this for the area. If I want to find this area is integral from a to b f of x dx. Yes, this is very, very simple. And if I want you to understand it better, I can write from a to b, instead of f of x, I can write y dx. Now, if I want to calculate this area, so let me call it a prime. So what is a prime now? What is a prime? A prime becomes integral from c to d, because now here I am looking here, y is changing from c to d, but what should I write here? X. Yes? So if I want to find the area in this case, I have to write, because usually they give me again y in terms of x. So your duty is to find x in terms of y and put it here, but integrate with respect to y this time. That's also true. That's also true for the ball. Any questions here? Okay, let me see if there are some examples if we solve them. Okay, so let us just solve the very simple problem here first. The simplest probably example is this one, and then that's a good example actually the book has chosen to work. So here, Let us just consider the famous parabola of y equals to x squared. And I just want to concentrate on this quadrant so I don't draw the other branch, not to confuse ourselves, yes? So I only concentrate here, and I am telling you that let us x be greater than or equal to 0. So that would be the curve. Okay, and then let us consider from 0 to 1. Yes? Y goes from 0 to 1. I take this and rotate it about the y-axis this time. So what it will generate, it will be something like that, yes? It will give me some kind of this object. And you want to find the volume of that object. So what should I do? Because I am rotating this volume about the y-axis, so it would be suitable if I use this formula. Yes? So what I do, I would write y is equal to pi integral, okay. Now, be careful here. You need to, because you are rotating about the y-axis, what matters for you is the change in y. In this region, y is limited between 0 and 1. Yes? So what you put here is 0 to 1. But what you need to write is x squared. Yes? And x squared dy. Yes? But what is x squared? X squared is y. So you put y here. Be careful, don't get confused. When you write this integral, it means that your variable should be y. And then x is actually not relevant, quite relevant here. You need to write x in a way that you can see the variable is y. So it means that you refer to your function, try to use that rule to express x in terms of y. But of course, in this case, you need x squared. It is already expressed in terms of y. You don't need to take a square root and square it again, because it's automatically y itself. So what you do is pi integral from 0 to 1 y dy. But can you tell me what is a primitive function for y here? Because the variable itself is also y, so it is exactly like x, but y. So what happens? It becomes y squared over 2. It goes from 0 to 1. And then if you calculate this, you put 1, it becomes 1/2. You put 0, it becomes 0. You subtract them, it becomes 1/2. Volume units. Yes? Of course, in this simple problem, you could do it a different way, which I don't want to do that, but I want you to understand that. You see, you could still, by the way, no, it is not working, by the way, or is it? So, if I want to avoid this, can I do it in a different way? For example, can I rotate this one about the x-axis? No, it's not a good idea, yes? Okay, now I can ask you a little bit harder question. I can ask you, I told you this is not part of the lesson, but this doesn't mean that you cannot solve this problem. Now assume that I rotate the blue part about the y-axis again. It will generate a solid object. It is, but again, in this case, you can find, without having a further knowledge about this, you can still find a volume, yes? How? Because you say to yourself, if I take the whole thing and rotate it, it will generate a cylinder. And I know that the height of the cylinder is 1, the length is also, the radius is also 1. So the whole thing is 1. And I have already found the volume here, then I subtract them, it remains what it is. But in general, it is not that easy. It was possible here that we can do it like this. Any questions? Okay, so that's also one other point that is expressed in the book. Okay, so let me solve some of these problems for you. If we are actually together, it is better to solve them together, okay? And if you don't mind, let me just jump directly to level 2 problems, not level 1 problems. One thing that I see is nice is this ellipse that you're supposed to rotate about the x-axis and the y-axis. Okay, so that is problem. In one of the videos I actually posted on YouTube, I solved some of the book problems in the book for the other group that I haven't solved for you. So if you are interested, you can actually watch those videos if you have some questions. So let me now do this here. So here you problem 5104 of this exponent 4, yes? They have given you an ellipse and they have written the equation for the ellipse. You need to take it for granted because finding an equation for ellipse is actually a little bit hard. So for example, if you ask GeoGebra, A and B are positive numbers and A is greater than B. This is called semi-major axis and that is called semi-minor axis. If you draw the graph of this function, this is not a function by the way, if you draw this, it generates an ellipse for you. Okay, centered here at the origin, and then this becomes A and this becomes minus A. Okay, I am just claiming it for you, so you take it for granted, okay? First of all, even if I didn't give you these numbers, you should be able to anticipate that minus A and A should be here and there. Can you see why? So let me clean them. And I give you 4 question marks here. Yes? So what are they? How can I find the question marks here? So let me compare it with the equation of a circle. Do you remember? If I give you this with the denominators equal to 1 and 1, this gives me a circle centered at the origin, radius 1. Yes? But there is no notion of radius in an ellipse because it is changing. You see here this is shorter, here it is longer. Yes? So you need to take this for granted. The equation of an ellipse looks like this, similar to the equation of a circle that looks like that. Yes? But my question for you is that if I give you this equation and I say that this is the graph of this, and I can ask you what are these numbers, in principle you should be able to find it immediately. Yes? What are those numbers? Because these are intersection points with the x-axis, so it means that I have to put y equal to 0. And if you put y equal to 0, this will vanish. X squared over a squared becomes 1. X squared becomes a squared. So x becomes minus and positive a. And I hope that you can immediately guess what will happen for these question marks. This time I want to find the intersection with the y-axis. So I have to put x equal to 0. If I put x equal to 0, this will vanish. Y squared over b squared is 1. Y squared becomes b squared. So y becomes negative b and positive b. Okay, so now the point is this. We want to rotate this object about the x-axis. It generates an egg probably, yes, somehow. That is called ellipsoid. Egg is not a complete ellipsoid, but if you actually rotate this, it generates a solid object like similar to an egg, and that is called mathematically an ellipsoid. And we want to find the volume of that ellipsoid. And then the book has asked you to do it in 2 So either rotate it, both we need to do. Rotate about the x-axis, rotate about the y-axis. Is it different? It will generate different things, you think? I don't see this. Yes, I think it will generate the same object. Yes, because by the way, my picture is very, very poor. If you want to be, it's completely symmetric. Do you think it will change if I rotate it about the x-axis and if I rotate it about the y-axis? Yes.
I think maybe the shape will change, but not the volume.
No, the way that I'm thinking is that the shape is not changed. Do you agree with me? I don't know, that's my intuition. It's a very poor picture. If you look at the symmetric picture, if I rotate it in that way or if I rotate it in that way, in this particular case, I'm not saying that is always true, but in this particular case it seems that yes?
A way of thinking about it, if you remove half of it and only look at the right side.
Yes, exactly.
The
Exactly. That is what
you will generate the left side.
Yes. So it means that the left side is not important. And by the way, I can just remove everything. Yes? And rotate this one and multiply it by 2. And rotate it in that way, multiply it by 2 again. And that is what we want to do because it makes it simpler. Anyway, let us calculate. So what is your prediction? Do we get the same numbers? Okay. Now tell me how to do it in principle. First of all, decide what you want to do. I want to take only this part. Of course, I can take this part. Let me see. I can take the whole part here and rotate it about the x-axis. I really don't need to care about the ones below, yes, because that will be the same thing. Okay. Or I can take only this part and rotate it, and then at the end multiply it by 2. Yes, that's up to you. But for me, the second one is easier because of calculations. But the point is that, first of all, for the x-axis, rotation about the x-axis, I need to write my formula. V is pi, integral, and then dx. Okay, can you tell me what should I write here, what should I write here, what should I write here? Because that is the important part for this lesson. At the end, you will get an integral, and then you have to solve that integral. So, you see what I am doing? I am taking this only. If you want, you can take the whole one. Yes? But if I take the whole one, I just rotate, that is exactly my volume. If I take this one, I rotate, but I have to multiply by 2. If you don't mind, let us concentrate on the second one. Okay, so I want to take this and rotate it about the x-axis. So this is clear, this is clear. What is this one? 0. What is the upper limit? A. But do you remember what I am supposed to write here? I am supposed to write y squared. Yes? Do you remember? It's still on the board. Here you see. If I want to rotate about the x-axis, that was the formula, but I can write it in that way. So here is y squared, but then I have dx. But y squared is easy to see from the formula. So I want to find y squared here. So what I do, I will take this one and move it to the other side. So it becomes y squared over b squared is equal to y 1 minus x squared over a squared. But I want to find y squared, so I multiply everything by b squared. Yes? And then I put it here. So this becomes b squared minus b squared over a squared x squared. Yes, is that understandable? So because I am rotating now about the x-axis, this is my formula. It was not hard to see that these numbers are 0 and a based on what I told you. And then here I have to write y squared. But y in terms of x, because x is my variable. So I went back to this formula and then tried to find y in terms of x. I don't need to take a square root sign because I need y squared. And then I have to calculate this integral, which is a very trivial integral. It's, obvious integral. So what should I do? Can you tell me? What is, let me test your understanding again. What is the primitive function for b squared? Yes, b to the power of 2x. That's good that you don't get confused. And then b squared over a squared is a constant. I pull it out. But then I need to ask myself what a primitive function for this one is, and that is x cubed divided by 3. And then I have to run it from 0 to a. Be careful. If I run it from 0 to a, I am getting half of the volume. I have to remember to multiply it by 2. Okay, you see that is simpler. Why? Because if I have chosen from minus a to a, then I have to calculate this once for a, once for minus a, and subtract here. There is sometimes you get confused about signs. But if I put 0 here, everything vanishes. I don't need to be worried about 0. I just need to be worried about this one. So this becomes pi, and then this becomes b squared a. Yes, and then this becomes b squared a squared, and then it becomes a cubed divided by 3. Yes? Now I think the volumes are different, yes? Let us see how it works. Because it becomes pi, this is b squared a. This a squared and this a cubed are simplified 1/3 of b squared a. So this becomes 2/3 of pi b squared a. But the volume that I am interested in is 2 times larger. So that is the formula. Yeah, it is a little bit counterintuitive. By the way, it makes sense because ellipse and spheres are very close. Ellipsoids and spheres are close together. So in a sphere, A and B are the same, and it's equal to the radius. And then if you put it here, it becomes 4/3 pi r cubed, and that's the formula for the volume of the sphere. Yes, but I think our prediction was wrong. The volumes are different. The shapes cannot be the same, because if the shapes are the same, the volumes have to be the same. So the volumes will be different. Can you predict what will happen if I rotate about? If I rotate about the y-axis, what will happen? I think the role of A and B will interchange. Yes? But if you want, we can calculate that one. In that case, the volume, because now I am rotating about the, if I want to rotate this about the y-axis, what will happen? The y goes from 0 to b, then it becomes x squared dy. But here, from this equation, this time, I need to calculate x squared. So it means that x squared over a squared becomes 1 minus y squared over b squared. Then I multiply everything by a squared, so it becomes a squared minus a squared over b squared y squared. And then I put it back here in this formula. So this becomes pi integral from 0 to b. X squared is what? This one. And then I will have dy. We really don't need to calculate, because if you compare this integral with that integral, everywhere here that I have a, there I have b, and everywhere that I have b here, I have a there. So if I calculate this one, this becomes 4/3 pi a squared b. Aren't they the same? I don't understand. Yes, let me see.
But the thing is, if you rotate it along the x-axis, you get kind of an egg shape. But along the y-axis, you get like a squished sphere.
It comes out of the board.
No, but egg is also a squished sphere, isn't it?
Yeah, but it's elongated square. I don't think they're the same because
They are not the same.
the
Yes.
middle circle
Exactly.
radius
That was my mistake. Yeah, I understand what you say now.
is B when along the x-axis and A along the y-axis.
Yeah, exactly. So we get a still ellipsoid, but exactly like that we have spheres of different sizes. We get the same shape, which is called ellipsoid, but with different sizes. Yes, exactly. Yeah, exactly. So we can imagine it like this. You see? Yes, you are right. So when I do this, assume that I have only this one, and I start rotating it. It will give me this. Yes? But now if I start rotating it in this direction, what it will give me is this one. Yes? Yes? And that's exactly the reason. This length is B, but this length is A. They can both be ellipsoids, but they are not of the same size. Yes? Yes, you are right. And then this can be seen here. Here, B squared appears, only A appears. But if you do the calculation here, that would be the other way around. I can also check that answer in this way. 5104. Yes, the answers we got are correct. AB squared for the x-axis. Yes, AB squared. So that's completely right. But it was I was a little bit careless to think that they will generate the same shape. They are not generating the same. The same shape, but with different sizes. Yes. Okay, so that is one problem. Okay, that would be good if I stop here. There is one thing that I haven't talked about. I will come back to this later. And that is exactly starting part of this section. I don't know why they have chosen to start with that, but anyway. I will come back and cover that one later. Not later, next session. So I will consider that this is not finished yet. Volumes of revolution, we will have one more. Okay, so we have to come to an agreement for the test, so please think about it. So because what is left here, I only consider test for these topics. One topic is left in the book which is related to how to use integrals for calculating continuous probabilities. Yes? I will teach you that, but that will not I will not take it for the exam. But the people for the national exam, they have to learn that because probably you will have that. Okay? So, because that's also an application. In this chapter, we are talking about the application of integrals. This is a good thing to see that integrals can also be considered somewhere completely different in probability theory. Yes? Okay, I will stop here and then you can practice because there are many good questions here. I will try to update the Google Classroom immediately so that you know what to do. Yes? Okay, thank you.
When do you plan to have the test?
Yes, let me just stop recording.